Alright, so on the same worksheet, as I said, I would do another example. So we have example 6 here. And there's a little twist on this question, as you see, but the method we use to solve it is going to be the same. So a rectangular area is enclosed by a fence and divided into another section of fencing as shown. If 600 meters of fencing is used, what's the largest area that can be enclosed? So, imagine this. You go out, you make a playground. Alright, or right in your yard, you put fencing all around the main part of the yard. But then you're going to subdivide it right here. Maybe you want to keep your dog over here, and this is your dog. I don't know. There. So you'll keep your dog here away from the kids, or a pool, or whatever. So you put in a large section of fencing, and then you subdivide it right there. But the most fencing you can use is still only 600 meters. Now, go back to the first video if you can't remember, but we said there's two equations you got to come up with first. So we're going to come up with one equation on perimeter, and we'll come up with one on area. So the perimeter question is how much fencing you got to deal with. So if we look here, we have, just let me change this color. So you have a length. Oops, nope, we don't call that length. You have a width. Hey, you get another width, and you get another one. And then you have a length that goes across the entire bottom, and then you get a length here. So we're going right across the top. So if you're keeping score here, we have two lengths, top and bottom, and then three widths. 1, 2, 3. And then area, well, area is still going to be, we want to know maximum area that can be enclosed. So for area, we're thinking all of this here, which is still going to be length times width. So we need to have a formula. You got to change this formula around and substitute into that one. So we always make our quadratic equation out of the area formula. Your area formula is the one that we always build a quadratic from. So it's either we have L squared or W squared. Doesn't matter which one. And we are leaving out one piece of information, that we have 600 meters of fencing. So if you took twice your length plus 3 times your width, you would have 600. So your perimeter, you know what's going to be, is going to be 600. So do you want to solve for W, solve for L? It doesn't matter. It's still going to work out. Okay, I'll solve for L in this one. I think the last equation we used, we solved for W. So I have, so you want to get, no, last equation we had solved for W. So let's just change it right here. So we're going to have 3W equals, so the goal here is to get W by itself. So we take the 2L, bring it over this side. So it's 600, subtract 2L. Okay, it's not so bad. Then we need to get W by itself, so you divide by 3. So we brought the 2L over, left with 3W. To get the W on its own, to isolate it, you divide by the 3, so every term gets divided by 3. So 600 divided by 3 is 200. And then you have 2 divided by 3, which is 2/3. So we can leave it as a fraction. You know, change to decimal, 0.67. You know, you don't need to do that. You can work with it as a fraction. It's not going to hurt you. So let's keep score of the equations. We have 1, 2, and this is our third equation. And we're going to sub this equation into that one. So substitute equation 3 into equation 2. Alright, so what does that look like? I have area, and we still have L, times, we don't have W anymore. W can't get replaced because that's what equal means. Equal means you can write it a different way. 200, subtract 2 over 3, L. And we need to simplify, so that means we multiply this out. $200 times L is 200L. Then L times 2/3 L. Well, look, if it was number in front, you wouldn't worry about it, so still don't worry about it. It's 2/3 L times L. L squared. You do not need to write it with the squared term in front. However, if some people are a little unsure, they can do that. So your L squared in front will be negative 2/3 L squared. So this went in front. And then you got your 200L. Your A, B, and C values. Your A value is negative 2/3. It's a number in front of the squared. Your B value is just in front of your variable without an exponent, well, an exponent of 1. And C, it's not there, so it's 0. And not required, but I do like to have a little graph there so I can just keep my mind straight on what we're doing here. So with this quadratic equation that we have, this one right here, area is here, L is here, which is your length. C always gives you your intercept on your vertical axis. So here's your vertical axis. 0 would be right here. So the graph is going to go up, through, and down. And we would know that because your A value is negative. If the A value were positive, it would have to come through and go up. We are not going to extend, we're not going to do this. Because that would make sense for a question here. So once you go below this line, your area values are positive here. As soon as you go below the axis, then they become negative. And that would make sense. You can't have negative area. So we're going to leave that out. Alright, so where does maximum area occur? At the vertex. These questions are called maximum or minimum questions, so this is a maximum. So you need to have the vertex, the horizontal, and the vertical, right? X, Y. And we always get our axis of symmetry. Our axis of symmetry will give us this value right here. What is the length that gives us the maximum area? So let's continue on over here. So to get your axis of symmetry, to get your length, it's negative b over 2a. So negative b, negative 200 divide by negative 2 over 2/3. Oops, that negative is supposed to be on the inside. And right now you might be looking at that and thinking, sir, this really looks a little gross right now. And it's really not that bad, believe it or not. So let's see how we're going to handle that. Let's give us a little more space here. So I intentionally left this as a fraction because some of you don't like fractions. So you get negative 200. And this means divide by, right? Divide by. Okay. So I'm going to write it horizontal. So instead of writing it stacked here, well, this means divide by 2 times negative 2/3, negative 200, divide by, well, let's multiply a fraction. 2 times 2, negative 4, and this is 2 over 1, so 1 times 3 is 3. Right? Multiplying fractions. Now, when you have division, you change and fractions, you change division to multiplication, and then you write the reciprocal, which means you flip your fraction over. And you learned that a long, long time ago, although you might have forgotten it. Negative times a negative, well, we get a positive. 200 times 3. Well, that's 600. And remember, we're multiplying fractions. Multiply across the top, the numerator, and across the bottom, denominator. 1 times 4 is 4. So 150. So this value should be positive. If this came at be negative, it would make sense because it represents the length. So you get a length of 150. And you could sort of stop here if you wanted. You only get 600 meters of fencing, right? Use 150 for the top. Use 150 for the bottom. Your 600 is now dropped to 300 meters of fencing left. And then you have a width. And these three lengths are the same. So if you divide that by 3, you get 100. 100, 100, 100. Add up all your numbers, you should come back with 6. 150 plus 150, 300, 4, 5, 6. So we know our width, and so we didn't need to go back to use our equations at all. You know, we reasoned that our width has to be 100. All right. Now, if you want to use your equations so to figure this out, well, we have a width here. Get a formula for that. And 1 second now. Okay. So your width equals, there, 200 subtract 2/3 L. Now you can reason it out or use your equation. 200, 2/3. We said the length was 150, right? Two times 150 is 300. Divide by 3 is 100. So your width is 100. And that's it, unless we got to find the maximum area. Let's go back and check our question. Remember this RTQ, read that question, so when you think you're done. What is the largest area that can be enclosed? Okay, so I do have to go back and find the largest area. So you can use your formula here for the largest area. Or you could do area is length times width. Length is 150, width is 100. (15,000 meters square). Or, and that's fine. I mean, you'll get full marks for that. Or go back and use your formula here. If you want to use your formula, area is negative, you say 0, put all this work and come up with this nice formula here, and I really want to use it. That's one. Let's actually make that look like 150. And yes, you are going to get some bigger numbers. So negative 2/3. Give me 1 second there, folks. Okay, 22,500, and you also get 200 times 150, 30,000. If you work all this out, multiply that by 2, divide by 3. Well, negative 15,000 plus 3,000, 30,000, sorry. And you come back with an area of 15,000 meters square, which is the same as, what we had just done. Flow. Alright, okay folks, that's it.